Good morning everyone. I am Pravatni from CACB and today I'll be presenting a seminar on Docker for developers, containerization and DevOps workflow. In today's session we'll explore how Docker helps developers package application efficiently and run them consistently in any environment from laptop to a cloud servers. And Docker has become a crucial part of modern software development because it's a bridge the gap between development and operation and enabling very faster, reliable deployment. So let's begin by seeing what's coming in our discussion. So here is what we are covering today. First, we'll understand what Docker is. Next, we'll compare the containerization and traditional visualization. Then we'll explore the architecture of Docker, its key components and how they work together. Then we'll move on installing the Docker, learning essential commands and writing Docker files. Then we'll talk about data persistence, networking, Docker Compose, and finally we'll look at a example project and end with a best practice and a brief comparison with the Kubernetes. So by the end of session, you will have a complete overview of how Docker simplifies application deployment and development. So, what is Docker? So, let us start with the basic question of what is Docker. So, Docker is an open source platform that allows developers to automate the deployment of application inside a lightweight and portable containers. So, now what is mean by containers? So, containers are like small self-contained environment that include everything need to run an application like code, libraries, dependencies, system tools that all will be in the container. The main advantage is consistency. So no matter where you run it, on your personal laptop, you are running in a server or in a production, the app behaves exactly the same. So it's not depend upon the local machines. Then the Docker solves one of the biggest problems in a software development. So the famous is it is famous for it works on many mission issues. Next, next is about the containerization versus virtualization. To understand Docker better, let us compare it with the virtualization. In traditional virtualization, we use virtual machine or the VMs. So each one of the VMs will run on complete operating systems on a top of a hypervisor. That means for every application, there is an entire OS running underneath and behaving it heavy, slow to boot, and resource consuming. So containers, on other hand, do not need separate operating system. So they share the host OS kernel, but they keep their process isolated. So this makes the containers extremely lightweight, faster to start, and far more efficient in resource usage. So if a virtual machine are like a separate house, each with their own foundation, containers are like a room in the same building, isolated, but they are sharing the same structure. So that is the power of the Docker. Let's move on to the Docker architecture. So the first is Docker engine or daemon. So this is the heart of the Docker. So it runs on the host machine and manages images, containers, networks and volumes. Next is the images. So they are the templates that contain everything your application needs. For example, a Python image includes the Python runtime, while a Node.js image include the Node. Then come to the containers. So they are running instance of images like your app in action. Next is Docker registry. This that is where the images are stored and shared like a Docker hub. Developers can pull up public images or push their own custom ones. So these components are work together to create, manage and distribute the containers easily. Next is installation workflow of Docker. So let us see how the Docker is installed. So first we'll prepare the system by using the commands like sudo apt update and or update, or you can do sudo apt upgrade. So then we'll add a Docker's official GPG key. Now we are going to set a repository. So that ensures that your package is all installed. So after that, we'll install the main packages like Docker CE or Docker CE CLE or Container IO. So these are the main packages you need for your Docker components. And finally, We'll verify the Docker service is active by using the sudo cement system shell status Docker. So once installed, we can run our Docker commands without the sudo by adding our user to the Docker group. So that's what the Docker is ready to use. These are the steps you need to follow. Next, essential Docker commands. So here are some basic Docker commands that every developer should know. That is Docker pull. That is to download an image from a Docker hub, you need to use Docker pull. Then Docker build. Build is to create a new image, or you need to start a new container, you can use this run container. Then to view all your containers, you can use Docker PS, and this Docker stop or this Docker RM that manages your life cycle. Whether you need to stop or remove the containers, you can use this. These commands that is in the previous slides, they daily once you are familiar with them, they can you can control your containers by just your starting and stopping the apps. Next, we are going to defining the image in the Docker file. To create your own custom image, Docker use as a file called Docker file. So Docker file is a simple text that contains a list of instruction like which image to use, which files to copy, and which commands to run. For example, you are using a Node.js app. You might start from Node. So you have to set your working directory, copy your files, install the dependencies, and then you have to start the app. So there are some best practice to avoid any time consuming or something. You can minimize the layers, that is a number of layers to reduce the image size. Use Docker ignore to skip any unnecessary files, and prefer using the copy instead of add. So with this we can create a reproducible environment for any app, just a few by running these all those commands. Next, we'll go to the volume, networking, and data persistence. One limitation of container is that is temporary. Once removed, the data is lost. To solve the Docker using volumes, volumes are external storage space managed by the Docker that store the data permanently and very useful for the database log. And networking allows a container to talk each other to the outside world. By default, Docker creates a bridge network, right? So but we can create a custom networks for the better isolation. And you can also use the ports, for example using 8080 colon 8080, so we can access the application running inside the container, so from our browser itself. So that is what the volume, networking, and data persistence. So once the data removed, the data should not lost. So we are storing the data temporarily. Then Docker Compose. So when we need to run a multiple containers like a web app, database, a cache, and managing them manually can be tedious. So that's where the Docker Compose helps. Docker Compose use single file called Docker Compile. Uh, Docker compile YML. So that to define all the services, networks, and volumes. So with that one command, that is this one command, Docker compose up and down. So all containers start together with the Docker compose down. So they'll all stop. If you want to start together, you can use Docker compose up. If you want to stop, Docker compose down. So it's a perfect for a full stack apps and testing environments. So it saves lot of time and ensures everything that run exactly as that is defined. Okay. Next is the slide of web app with a Docker. So let us take an example. Let us take an example of simple web applications with is built with Node.js and MySQL. So we'll write the index. We'll write the Node.js app with a few files. So let us take an example, right? So we write our own Node.js app with a few lines like index.js and package.js, and we'll create a Docker file to build the web app image. Next, we'll create a Docker compose YME file, YML file to define both the web service and MySQL database service. So finally, we'll run the Docker compose Both the containers start automatically and we can access the local host